Okay, good day. Today's discussion is all about the quarter 3 of Module 1, entitled The Fundamental Counting Principle and Permutation of Objects. So first, we are going to discuss about the counting principle. So how are we going to make use of this principle? First, I have an example. Mr. Yuzu has two shirts, three long pants, and five sneakers. So how many different outfits can he wear if he picks one shirt, one long pants, and one sneakers for his outfit? So we have three things here. So this first blank here denote as the shirt. The second one will be denoted for the long pants, and the third is for the sneakers. So since we do have two shirts, and we also have three long pants and five sneakers, so all we have to do here is we will just simply multiply the 2, 3, and 5. So therefore, there are 30 different outfits. Okay, next example. Find the number of different 7-digit telephone numbers where first, the first digit is 0, the second condition is without the last digit is greater than 5. So we'll first answer the first problem. So what if the first digit is 0 in the 7-digit telephone number? So take note, class, that there are how many numbers are there? So there are 10 numbers, that is from 0 to 9. So take note that the first digit here is 0. So how many zeros do we have from 0 to 9? There is only 1. So since this is a 7-digit telephone numbers, or this is a telephone numbers, the repetition of number is allowed. So therefore, on our second digit, we can choose from 0 to 9, and there are 10 ways. Okay, 10, we do have 10 choices. For the third digit, still repetition is allowed because this is a telephone number. So we do have 10 choices still. For the fourth digit, there are 10 choices. For the fifth, we have 10 choices. For the sixth digit, we have 10 choices. And for the last digit, the seventh digit, we also have 10 choices. So if we are going to multiply everything here, this will give us 1 million. So there are 1 million different 7-digit numbers can be formed if the first digit is 0. What about for the B? What if the last digit is greater than 5? Okay, so take note, we do have 7 digits here. The last digit must be greater than 5. So what are the numbers that are greater than 5? And that would be 6, 7, 8, 9. So there are 4 numbers that are greater than 5. So that would be 4. So take note again, this is a telephone numbers where digit can be repeated. So for the first digit here, there will be 10 choices, so from 0 to 9. The same with the second digit, there are 10 choices for the third, fourth, fifth, and the sixth digit. So if we are going to multiply everything, we will come up with 4 million different 7-digit numbers. Can be formed in a telephone number. So there are 4 million. Next. So Next topic is factorial form. So how do we evaluate factorial form? So say for example, 6 factorials. 6 factorials can be written as, so this is 6, so that would be 6, 5, 4, 3, 2, 1. So the product of 6 up to 1, so 6 times 5 times 4 times 3 times 2 times 1 is equals to 720. What about 4 factorials? So 4 factorials will be the product of 4, 3, 2, 1. And thus, it will give us 24. That is for the factorial form. Now, we'll proceed on to permutation denoted by NPR. So that is the n times taken are at a time, the NPR. So I have here, okay, I have here 4 examples. So for number 1, that is 4 taken 4. So 4 taken 4 can be written as, we will start, there are 4 numbers and we will use 4 numbers. So there are 4 numbers given and we will all use the 4 numbers. So what would be the result? So 4 taken 4 is, we will use 4. So 4 times 3 times 2 times 1. Okay? So the product will be equals to 24. What about 5 taken 2? So there are 5 numbers, that is 1 to 5, and we are going to make use only of 2 numbers. So 5 taken 2 at a time will be, so we will start with the highest, then the next number. So 5 times 4. Why is it 5 times 4? Because we will be using only 2 at a time. So instead of 5, 4, 3, 2, 1, so it would be 5 times 4 only. Okay, this 5 taken 2, and 5 taken 2 is equals to 20. 7 taken 4. Okay, for 7 taken 4, so there are 7 numbers, we will be using only 4. Or 7 objects, and we will be using only 4. So this will be expressed as 7 times 6 times 5 times 4. So there are 4 numbers that is being used. So that is 7 taken 4, and 7 taken 4 is equals to 840. So we'll multiply from 7 up to 4. So for 8 taken 3, this is quite clear now. So 8 taken 3, that is 8 times 7 times 6. Because we are going to use only 3. So 3 at a time. So 8 times 7 times 6. And 8 times 7 times 6 is equal to 336. Okay, next. Let's now proceed to, okay, so we are to find the numbers of the unique permutation of the letters in each word. So for number 1, we will be using it, in which we are going to use all the letters. So there are, how many letters are there? So there are 3. So 3 taken 3. So 3 taken 3, that is 3p3. So 3 taken 3 is simply 3 times 2 times 1. So thus, it will give us 6. What about the hate? Okay, the hate words. So we'll be using all the letters again. That is 4 taken 4. So for 4 taken 4, that is 4 times 3 times 2 times 1, in which it will give us 24. What about the word creation? So for the word creation, we will use only 3 letters. So how many letters are there in a word creation? And there are 8. So there are 8 taken 3. So 8 taken 3 is 8 times 7 times 6, and that is equals to 336. What about the word hyper? The word hyper, so we are going to make use only of 2 letters. So how many letters are there in a word hyper? And there are 5. So that would be 5 taken 2. And 5 taken 2 is just 5 times 4. And the answer is 20. Okay, now let's apply this into our problem solving. There are 8 contestants in a marathon. It is given that the contestants has an equal chance of winning and losing. So how many permutations are there for the 8 contestants? So there are 8 contestants, and we are going to arrange this one using 8. So that is 8 taken 8. And what is 8 taken 8? That is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And it will give us the 40,320 ways. Okay, what about if only the first, second, and third will be chosen? So from the 8 contestants, we are going to choose only the first, second, and third. So 8 taken 3, or you could use the counting techniques. So we do have 3 unknown here. So for the first, second, and third. For the first place, so since there are 8 contestants, there are 8 choices. For the second, so what do you think would be the number here? It would be 7. So why is it 7? Because we do have a first place. So we are using 1 contestant in here. So therefore, we now have 7 choices. And what about the third? For the third, since we are using the 2 contestants here for the first and second, and there will be 6 choices. So 8 times 7 times 6 is 336 ways. Okay, another problem. There are 7 cards numbered from 1 to 7. So how many 3-digit numbers can be formed if arrange them in a row? That is the first question. The second question is, what if the 3-digit numbers will be even? Okay, so we will be solving the 3-digit numbers. So there are 7 cards taken 3. So 7 taken 3, and that is 7 times 6 times 5, in which the answer is 210 ways. So why is it 7 taken 3? There are 7 cards, and we are going to make use of 3 cards. Diba? 3-digit numbers can be formed. So we'll be using 3 cards. So 7 taken 3, so 7 times 6 times 5, and that is 210 ways. Okay, what about if the 3-digit numbers will be even? Okay, so from the 7 cards, so assuming that we do have 3 cards because we are going to get 3-digit numbers, so we need to get 3 cards. But how do we know that the number formed will be even? Okay, it will be even if the third card will be even. So okay, so a number becomes even if the last digit is even. So that is 2, 4, 6, 8, 0. But in this case, the numbers is only from 1 to 7. So how do we know? Okay, what would be or the choices. So how many choices do we have for the third card to become even? Okay, so that would be 2, 4, 6, and that would be 3. And now, for the first card, so there's no what? Okay, there's no rules regarding on the first digit. So in this case, since we are using one card on here, so since there are 7, this would be 6. And here we are now using 2 cards. So how many choices do we have on the second card? And that would be 5. Okay, so now we do have 3 cards. Will form 3-digit numbers. So 6 times 5 times 3 is equals to 90. So there are 90 ways to form a 3-digit numbers in which it is even. Okay, now, so your turn. So I want you to answer in the quarter 3 module 1. So you will answer only the pre-test, activity 3, activity 4, and the post-test. Thank you for your time. God bless us all.